8, and it says to determine the velocity and acceleration of the peg A, which is confined between the vertical guide. So this is the vertical guide for peg A and the rotating slotted rod. The slotted rod has a gap between it, and its width is perfectly to fit peg A in it, but it can freely move within that. But it is limited to the vertical guide. It cannot displace anywhere else. So from the diagram we can see that the movement of the peg is vertical only. It cannot move in any other direction. It's upwards or downwards, which mean the vertical movement. And then in the diagram we can see the distance of O from the vertical guide is B, and there is angle theta with the horizontal of the rotating slotted rod, and the angular acceleration and the angular velocity has a direction which is anti-clockwise. So in this question we can see there are no numerical values given, so we have to find the velocity and acceleration in form of theta and B, because these are the two variables given in the diagram. So when we start our answer, we can draw a simpler diagram in form of right angle triangle. As we can see that there is a right angle between the vertical guide and the horizontal base, and the distance from the vertical guide to the O, the horizontal distance, which is B, and we consider that the vertical distance with peg A is Y, which varies with the angle theta. So as we're finding the vertical velocity, because the velocity and the acceleration of peg A will be in the vertical direction, so we use y is equal to b tan theta. So y is actually the vertical displacement. You can call that vertical distance or displacement traveled by the peg A. We will call displacement because it has a specific direction which is vertical. So to find the velocity, we know that if we differentiate displacement, we get velocity. So dy over dt is equal to v, where y is the vertical displacement. So when we do that, so we have to differentiate with respect to t on both sides, but over here we can see that it is in form of theta, the equation. So we have to use a chain rule. So in chain rule, b comes on the side because it is a constant which is being multiplied to the tan theta. So b comes out and the remaining term is differentiated. So d over d theta tan theta, and the chain rule d theta over dt. So d theta over dt, as you know, is omega, which is the angular velocity, because theta is the angular displacement. And the differentiation of tan theta is secant square theta, and b remains as it is. So velocity becomes omega b secant square theta, where omega is the angular velocity and b is the horizontal distance of O to the vertical guide, and theta is the angle of the rod with the horizontal base, and it varies. So this is the velocity. Now we have to find what is the acceleration. So acceleration is differentiating velocity with respect to t. So we take the previous equation we find as velocity and differentiate it. So as you can see in the previous equation, we have two separate terms. One is the omega term and one is the b secant squared theta term. And because both of them are like variables where only b is the constant and there are two variables. So as you know that when differentiating such equations we have to use the product rule. So in this, the product rule, we differentiate omega with respect to t and b secant squared theta remains as it is. Then we plus and then omega remains as it is, and then we differentiate b secant squared theta. Similarly to what we done before, we will use a chain rule for secant squared theta, and there will be d theta over dt over here. So our term will be a is equal to b secant squared theta, and d omega over dt is angular acceleration. So when we differentiate angular velocity with respect to t, we get angular acceleration. And omega comes as it is, so does b. And secant squared theta, when we differentiate this, it forms 2 secant theta because 2 comes in front, and the power -1 in power we put -1 and it becomes theta, and then we multiply with secant theta tan theta, which is the differentiation of secant theta, and then we multiply with omega because d theta over dt is omega, and then a is equal to b secant squared theta multiplied by angular acceleration plus 2 omega square b secant squared theta tan theta, and then we just simplify the equation in form of acceleration of peg A is equal to b secant squared theta. In bracket we put angular acceleration plus 2 omega squared theta tan theta. So this is how we find the velocity and acceleration of peg A. So the simplest thing to do is in this is to draw the diagram, and then it's basically calculus in which you do the differentiation. But in this you have to keep in mind that you are taking the vertical displacement.